Hello guys, welcome back to my YouTube channel. So today's daily LeetCode question is nth Tribonacci number. What is a Tribonacci number? The Tribonacci number is nothing but the sum of the previous three numbers is the Tribonacci number. So to understand a Tribonacci number, so you have to have basic kind of Fibonacci number. So let us take a 0 and 1. The Fibonacci series starts from 0 and 1. So let this index be 0 and this index be 1. So the second index will be the sum of these two. It will be 1. And the third Fibonacci series number would be sum of these both numbers. So it will be 2. The fourth Fibonacci series value will be the sum of the third Fibonacci series value and the second Fibonacci series value. So the sum will be 3. So like a Tribonacci series. Now what is a Tribonacci series? Tribonacci series is nothing but if it starts from 0, 1, if we combine this word it would be 1, so 1. So 0th Tribonacci series number is 0, first Tribonacci number is 1 and second Tribonacci number is also 1. The third Tribonacci's value will be the sum of these three. So it would be 2. The fourth Tribonacci series value would be sum of these three. It would be 2, 1, 1, 4. And fifth Tribonacci series value would be sum of these three, which means 6, 7. So it means if we want to find the nth Tribonacci value, so we need to find the n minus 1 plus n minus 2 plus n minus 3. Okay. Now let's look into the possible approaches of this problem. Okay guys, now let's look into the constraints of this problem. So our n value is greater than 0 or n less than or equal to 37. So it means 37. So if the n value size is less than or equal to 100, so our time complexity should be big O of n. Okay guys, if the n value is less than or equal to 20, then our time complexity can be big O of 2 power n. So to solve this problem, we have two approaches. The first approach will be a recursive approach, where it is quite clear the same approach we will follow in Fibonacci series, and another one is DP approach. Now this is dynamic programming and this is recursive. So let's look into the recursive approach first to look into our solution. So in recursive approach, we will just first check the base conditions. Now our base conditions are if n equal to 0, we will return 0. If n equal to 1 or n equal to 2, we will return 1. Okay guys, else we will return 0. So this is the first condition, this is the second condition, and our third condition is we will return the, now if our n value is greater than 1 and 2 and 0, then we will just calculate the recursive function Tribonacci of n minus 1 plus Tribonacci of n minus 2 plus Tribonacci of n minus 3. Okay guys, so this will be our recursive approach, and if we use this recursive approach, our time complexity will be big O of 3 power n, because here we are making 3 function calls and each function call will have its own tree. So it will take 3 power n time complexity, which is very large, and we may face the time complexity exceeded error. So we will move to the dynamic approach. Before moving to the dynamic approach, I want to show the code for the recursive approach. Let's look into the code for recursive approach. This is the solution for the recursive approach, and we will be given an input n. If our n equal to 0 or our n equal to 1 or 2, we will be returning 1 and 0 respectively. Else we will just make a recursive function call of n minus 1, n minus 2 and n minus 3. So this will lead to our time complexity of space 3 power n, and this will be a more complexible program. So can we reduce this by using any other techniques? So the answer is yes. So we can reduce this by using another technique. So that is the DP approach. Now we will discuss our DP approach. So our DP approach is, we will be using a array of size n. If our input is 4, so our array size will be n plus 1, means 5. So why 5? Because we have indexes from 0 to 4. If we want indexes from 0 to 4, we need 5 spaces array. So our array size should be n plus 1. Okay guys, so 0th index, first index and second index, third, 4. So this will be eventually 1 2 3 4 5. So we will just hard code the first 3 values of the array, because we have to compute the further values based on the previous values. So we need to hard code the 3 values. So if our n value is 0, we will just return 0. Our n value is 1, we will return 1. If our n value is 2, then also we will return 1. So we will hard code these values, and we will start our loop from 3 to n. So we will start our loop from 3 to n. So here you can see that if we want to compute the third index, we can simply say that if I want the third index, then my answer would be 3 minus 1 plus 3 minus 2 plus 3 minus 3, right? 3 minus 1 is 2, second index value plus first index value plus 0th index value, which is nothing but 1 plus 1 plus 0. So this sum up should be 2. If I want the fourth index value, then my sum up will be 4 minus 1 plus 4 minus, so 4 minus 1 is 3, 4 minus 2 is 2, 4 minus 3 is 1. So this sum up will be 4. So the answer will be 4. At the end of the iteration, we will just return the DP of n. I hope you got the institution and solution video. Let's look into the code explanation. Okay guys, this is our DP solution. So we can clearly see that if we are considering our base cases, if n equal to 0 or n equal to 1, we will just simply return 0 and 1. No need to have any further discussion. Then we will create an DP which is size of n plus 1, and we will hard code these 3 values. Then we will start our iteration from index 3 to less than or equal to n, and we will just compute the previous values and put in the latest value. So first we will put the third index value by computing the second index value, first index value and 0th index value. Then it will be the third index value, then so on till the end n. So let's look at a simple dry run. So if our n value equal to 5, so here we will have an array of 6 indices, right? 3 4, this is 6 index. So 0 1 2 3 4 5. So we have hard coding the 0th index with 0, 1 index with 1 and second index with also 1. So we will start from 3 and we will iterate till the 5. So now the third index value will be the sum of the second 0 and 1. It will be 2. The fourth index value will be the sum of 3, 2 and 1. It will be 4. The fifth index value will be the sum of 4, 3 and 2. It will be 7. So at the end of the iteration, we will be returning the dp of n. dp of n is nothing but 7. So 7 will be our answer. I hope you understand the solution code explanation. So please like, share and comment. Thank you.